In the previous lesson, we learned that a logarithm answers a simple question. What exponent produces this result? We also learned how to convert between exponential and logarithmic form, evaluate logarithms, and work with common and natural logarithms. But what happens when the logarithms become more complicated? Evaluating expressions directly can be difficult, but mathematicians discovered a set of powerful rules that allows us to break complex logarithms into simpler pieces. In this video, we'll learn the three most important logarithm properties: the product rule, the quotient rule, and the power rule. Then we'll use these rules to expand and condense logarithmic expressions. Finally, we'll learn the change of base formula, which allows us to evaluate logarithms with any base using a calculator. By the end of the video, you'll have the tools needed to simplify logarithmic expressions and solve many of the problems you'll encounter in Algebra 2, Precalculus, and beyond. So let's get started. The first rule we'll discuss is a product rule. We're going to apply the one-to-one property first of all. So this rule says that the log base b of m is equal to the log base b for n. So an example here would be log base 3 of 3x equals the log base 3 of, let's say, 2x plus 5. Since both of these have the same base, then I can cancel out the log base 3's, and I can rewrite it as 3x is equal to 2x plus 5. Okay, let's take our 2x over to the other side. So that would give us x equals 5. So the simplest form is a one-to-one property when everything has the same base. Now let's discuss the product rule. So we can say that log of base b for mn. Okay, so we can break this apart. Since this is multiplication, we can say then that log of base b for m plus the log base b for n for any base b which is greater than 0. So let's expand log base 3 for 30x times 3x plus 4. I can say log base 3 for 30 plus the log base b, base 3 rather, for x plus the log base 3 of 3x plus 4. All right, you cannot break apart addition or subtraction here. So you had to keep them together. Okay, so this will be fine, but sometimes your instructor wants you to convert all the products into prime numbers. It's not necessary, but sometimes you see it where you had to have everything in primes. So this 30 here. Okay, for this 30 here, we know that 30 is equal to 6 times 5, which is 2 times 3 times 5. So there we have all the prime numbers. So if that's the case, then we could say log base 3 or 2 plus the log base 3 of 3 plus the log base 3 of 5 plus the log base 3 of x plus the log base 3 of 3x plus 4. All right, so either one of these are correct. So you could have this for your answer, and it should be fine. But if you had to have it in prime numbers, then this will be your answer. Okay, let's do one more product rule. So let's expand log base b of 7x times 2y. Okay, so we're going to take log base b of 7. Since 7 is multiplied times x, so we'll say plus the log base b of x. Again, we're multiplying, so we'll add log base b of 2 plus the log base b of y. So that's pretty much all the product rule is. When you're multiplying, you're breaking it apart into separate log statements. The quotient rule for logarithms is very similar to the one used with exponents. So log, let's say base b for the fraction m over n will be the log base b of the m. And since we're dividing, we will subtract, like we would with exponents, the log base b of n. So that's basically the format for the quotient rule. Okay, so let's try an example here. So let's expand log of, let's say, 2x squared plus 6x divided by 3x plus 9. All right, first thing I always look for, I look for lowest terms. Okay, I see that I can factor out a 2x. So let's do that. The top expression. So it'll be 2x times x plus 3. In the bottom, I can factor a 3, can't I? So if I factor 3, that'll be x plus 3. Okay, so let's cancel our common factor. Our common factor there is x plus 3. That would leave us with the log of 2x over 3. Okay, let's take it a step further. That means the log of the numerator minus the log of the denominator. Okay, let's look at this example. Okay, I can't factor anything. So let's just go ahead and use the quotient rule. So I can say that log base 2 is going to be 15x x negative 1 minus the log base 2, 3x plus 4 let me go ahead and group this. Okay, now what we could do is we could use the product rule to go with this. By doing so, we could have log base 2 of 15 plus log base 2 of x plus the log base 2 of x minus 1 minus log base 2 for 3x plus 4 minus the log base 2 of 2x minus 1. Okay, notice what we did here. I was distributing this negative sign across all of this, so I had to say negative times positive gives me negative both times, negative and negative. So this will be the answer. Okay, this leads us now to the power rule. So the power rule uses the format log base b of m raised to the nth power. So this is essentially the same thing as taking the n, moving it to the front. So we would have n log b for m. So some examples could be like log base b for x squared. Bring the 2 forward. That would be 2 log b for x. All right, watch out. Sometimes a problem will try to trick you. So what will happen is the logarithm may not be written as a power. It may have like 100. But remember, 100 is 10 squared. Or if you see like the square root of 3, that will be like 3 raised to the 1/2 power. Or you see something like 1 over e, that will be e to the negative first power. So watch out for those. All right, a couple more examples. Let's say log base 2 of x to the 5th power. That would be 5 log base 2 for x. Say log base 3 of 25. Well, that would be log base 3 of 5 squared, which is 2 log base 3 or 5. The natural log of 1 over x squared. Okay, so that's equal to then the natural log. Bring the x to the numerator. So I'll take the reciprocal of that. So that will be x to the negative 2. So I change the exponent. And now I can say minus 2 ln, or natural log, of x. That would be the answer to all those problems. Okay. When expanding logarithmic expressions, we can do this with products, quotients, powers, or roots, but remember, never with addition and subtraction. So, log base b of 6x over y. Okay, so I would start off by saying, well, log base b, let's put these on the same line. So that would be of 6x minus log base b for y. So that'd be log base b of 6 plus the log base b of x minus the log of base b of y. Another way of approaching a problem similar to this would be something like log base b of a over c. So we could say this would be the log base b of a. Okay, I'm going to put a plus here. Log base b of c to the negative first power. And it would give us the same outcome as above, log base b for a. Bring this forward to the front, minus the log base b for c. Okay, so here's some more to practice with. So I have the natural log of x to the fourth times y divided by 7. All right, so I guess first of all, let's go ln of x to the fourth y minus the natural log of 7. All right, so now we can expand. So this be the ln of x to the fourth plus the ln of y minus the natural log, or ln, of 7. Bring our 4 forward using the power rule. So it'll be 4 natural log of x plus the natural log of y minus the natural log of 7. Okay, let's try the next one. So this will be the log of the numerator minus the log of the denominator Okay, so this is going to equal then the log of x squared plus the log of y to the third minus the log of z to the fourth. Okay, so let's bring our 2 forward, so it'll be 2 log of x. Bring our 3 forward, 3 log of y minus 4 log of z. So this is going to equal the log of x to the 1/2 power. All right, so I use the power rule then, so I can say it's 1/2 the log of x. All right, the next one, the natural log of the cube root of x squared. Well, this will be equal to the natural log of x to the 2/3 power. So I use the square over the root. That's what I did there. So that will be 2/3 the natural log of x. Okay, so expand the ln or natural log of x squared plus y squared. All right, there's no way. The reason why, because we cannot do addition or subtraction as part of the argument. So watch out for those tricks like that. Okay, let's expand this one. Okay, so I'm going to say this is equal to, let's write the top first, so it'll be the log base 6. And I'm going to go ahead and, instead of doing it step by step, I'm going to skip a couple steps. So I'm going to go ahead and say log base 6 for 64 plus the log base 6 for x cubed plus the log base 6 for 4x plus 1 minus the log base 6 for 2x minus 1. Remember, if a addition or subtraction is within the argument, you have to leave it alone. Can't do anything more with it. Okay, this 64 looks suspicious, doesn't it? 64 will be 2 to the 6th power. So let's substitute that. Log base 6 or 2 to the 6th power Okay, so let's bring our 6 forward. So that'll be 6 log base 6 for 2. Okay, our 3 using the power rule, so that'll be 3 log base 6 for x plus the log base 6 for 4x plus 1 minus the log base 6 for 2x minus 1. Okay, this will be our last one where we're showing examples of expanding logarithmic expressions. All right, so here we have natural log and a bunch of stuff under a radical sign. So the first thing I would do is get rid of the radical. I'm going to say that this would be 1/2. Now the ln, and then we can go ahead and write all this out. X minus 1, 2x plus 1 squared, x squared minus 9. All right, so we'll say then that's 1/2. I'm going to put a bracket sign, because that'll be the ln of x minus 1 plus the ln of 2x plus 1 squared minus the natural log of x squared minus 9. All right, so let's take this. So x squared minus 9, that's going to be equal to x plus 3 times x minus 3. So instead of writing the whole thing again, I'm just going to substitute here. This could be minus okay, so now let's go ahead and finish up, because I can bring I can bring this 2 up here. So we have 1/2 natural log of x minus 1 plus 2 natural log of 2x plus 1. Okay, so I'm going to put a minus distributed across all this. That'll be minus the natural log of x plus 3 minus the natural log of x minus 3. Okay, and that should be our answer. Okay, so now let's do the opposite of expansion. Let's condense some logarithmic expressions. All right, so let's try the power rule first, then the product rule, then the quotient rule. That's kind of the way a lot of people do it. Okay, so we're adding, and since these are the same bases here, if I add them together, then I could have log base 3. This be 5 times 8 minus the log base 3 of 2. Okay, so this would be equal to the log base 3 of 40 minus the log base 3 of 2. This should be the log base 3 of 40 over 2. That's equal to then the log base 3 of 20. Okay, on the next one, I'm going to get these are my positive ones, so I'm going to group those together. Of 3 times 5. Now let's group the negative ones. That'll be 4 and 6. So that'll be 4 times 6. So this would be the log of 15 over 24, which equals the log of 5 over 8. Okay, let's condense one more. Okay, let's do our power rule first. So the power rule, I'm going to say log base 2 x squared plus, okay, let's take care of this half. Let's bring the half back over to the other side. So that'll be log base 2. So this will be the square root of x minus 1 minus, take this 3 over. So it'll be log base 2. Okay, so that'll be x plus 3 to the 6th power. Okay, now let's do the product rule. All right, so that'd be log base 2 for x squared times the square root of x negative 1 minus the log base 2 x plus 3 to the 6th power. Now the quotient rule. So I'll say the log base 2 x squared times the square root of x minus 1 over x plus 3 to the 6th power. Change the base formula for logarithms. I'm going to be using the format here of log base b for m. Now I'm going to change this to a different base. Now we have to rewrite it either in a logarithm of a common or a natural log. So I can say log base b of m could equal the log of m divided by the log of b. Now we're assuming now our base is not equal to 1, of course. So an example here would be something like log base 5 of 3. Okay, this could be equal to the natural log of m, which is the 3, over the natural log of the 5. Or if I wanted to do it in terms of common logarithms, I could say the log of 5, or excuse me, base 5 for 3 will be the log of the 3 over the log of the 5. And you have to solve these with a calculator. Before we finish, let's review the key ideas from this lesson. The product rule allows us to turn multiplication into addition. The quotient rule allows us to turn division into subtraction. The power rule allows us to move exponents in front of a logarithm as coefficients. Using these three properties, we can expand complicated logarithmic expressions into simpler parts or condense several logarithms into a single expression. We also learned the change of base formula, which allows us to evaluate logarithms with any base using the common logarithm or the natural logarithm functions available on your calculator. These properties are much more than algebra tricks. They are powerful tools that will help us simplify expressions, solve logarithmic equations, solve exponential equations, and model real-world situations involving growth and decay. Make sure you spend some time practicing both expanding and condensing logarithms. The more comfortable you become with these properties, the easier future logarithm problems will be. Thanks for watching, and I'll see you in the next video. If you found this video helpful, please be sure to check out other lessons on this channel. Please leave a comment, like, and subscribe. Thank you for watching.